Okay, today's tutorial is a Fusion 360 one. We are going to be learning how to do relationships and joints so we can get our models to both move in an animated style like this. Although this animation isn't actually the main goal of here, the main purpose of this is so we can change particular lengths of our model, and as we do that, we can do things like measure our model at different states of the parts being related. Why this is different than making each individual part just manually moving it is if you were to regularly just move this thing, the top part of this bridge here, the piston would also not move at the same angle. So it would not look like it's moving in the correct direction. So here we have multiple parts that are moving in relationship to each other. As you're doing this tutorial, as you're following along, the actual size of things don't matter. Don't ask me unless it's really, really important. The actual lengths of the parts. This tutorial is going to be in two parts. We're going to make two different objects, as you see here on the side. And this is the example I did this morning. So you're going to do a similar one. We're going to do another one for the tutorial. But I'm making two different models for this. One of them is going to be, I have here the word hydraulic, but technically that I should rename that as the bridge. We're going to have one part of the bridge, and I'm going to have one part for the piston itself. So we're going to start by building the bridge, and then we're going to build the pistons. And then you can add more details to it later, or realistically, when you do your own assessment task, you might redo this completely to match your task. And you'll have the bridge, and you'll have the box, and you have the claw. You can do the motion for all of those. So I'm just going to keep this file open so we can refer to it, so we can see how it looked. All right, so we're going to start by new design. When we do new design, we're going to start with a part design, and we're just going to create new. Now, as we saw from my example previously, the bridge was a very, very simple bridge. So simple that it was just two rectangular prisms. So I'm going to start by sketching. I'll sketch on my XY plane. The base of the bridge is just a 50 by 50 square. I'll finish that sketch. I'll press the E button to extrude, or I can go here and manually press the extrude button. And I just want this length to be 50. And I just want to start with a cube. Very simple shape. Your bridge would look better. You can design it with your paddle pop sticks and your wood. Your paddle sticks and your cardboard. You can make it look like your actual bridge. But this is just a simple object for now. And then we want to make the top part of the bridge. So we're going to do sketch again over here. And when we sketch it, I'm going to start in the corner here. And I wanted mine to be 10 mil high by 100 mil long. And press enter. Now, as I do this, a careful thing I want to do is I want to make sure they're not actually overlapping, because I want this to be a new part. So when I finish this sketch, I'm going to go over here and I'm going to press the extrude button again. And I want it to be 50. Yep. The bottom cube is 50, 50, 50. And the long one is 10 by 100 and 50 long. When you're doing this part, you want to make sure when you're extruding it that if it does overlap, it will want to either make a join or a cut. We don't want that. We want this to be a body on its own, so we want to make sure it's a new body. And to here in our sketch here, if we can look at our bodies, we have two separate bodies. And then later we can add more details to these. Later I'm going to show you how, as we do our drawing, so as we do our I think it's called an assembly. When we assemble it together and we have the moving parts, we can then customize here, and it should automatically update our better looking drawing. So I'm going to save this. I'll press the save button, and I'm going to put it into our file. For this one over here, it's going to be stage 5, and I name this 2026 task 3 tutorial, and I'm going to call this the bridge. Save, and I'll save this. All right, then we'll look at my actual example here. The other thing I needed to add here, I have to add these little hooks here. So I'm going to show you how to do that. So for this, I'm going to pick the location of these hooks. And this is when, like, if you've done your sketches, you'd have a rough location where your hooks will be. And when we actually get our syringes, our plastic syringes in from Amazon, we'll actually measure them and look at our sketches, and we'll get a rough location of them, because I guessed here that the location of these syringes where they would match in our design would be somewhere here, which is like not exactly the middle, but roughly there. And this one's roughly in the middle. So I'm just guessing the location for this. I'm going to sketch from the bottom of this panel over here. And I am going to just make a rectangle in a place that looks like it makes sense. And when you do this, we want it to be symmetrical. So what am I going to do? If I want to make it look properly, I'm going to make a midline. I'm going to make a line from here to here. Okay. And then I'm going to do the create. I'm going to do a rectangle and I'm going to do it from the center. So then as I drag my line across here, a triangle should show up at the midpoint. Because I don't care about where this is from the left and right or in the X plane, but I do care about it to be in the middle of this object because that's where it'll be on our bridge. Obviously in your model, you might not have it in the middle. You might have them on the side. So you would change that in design, but in my one, I have it in the middle. And then once I do that, I'm going to make a shape, and this shape will be 10 high by 5 wide. This is going to be the little hinge that my syringe will hook onto as the top part of the syringe can rotate. So in here, it's this little part here is what we're making, these two little holes. I finished that sketch, and now that I have that shape, I'm going to press extrude, and I want to press these two surfaces, and I just want to turn this into a square, so I think it'll be 10 high, 5 high. And so what I've done there is I've just made a little rectangular prism underneath the top of my bridge. Then I'm going to sketch that face, and on this face I want to make this look like it's going to have the hole and it's going to have the curves on the edge. So I'm going to do that over here. I'm going to first find the midpoint here by getting a line, and I'm going to do a diagonal line here and a diagonal line here. This will give me my rough location if I know where the center of my circle will be. I'll make my circle diameter. Now, if we measure the size of the axles we have in the workshop, we can already make this hole. I think our axles are going to be 3mm diameter, so we can just type in the number 3. I'll press OK, so that's going to be the center hole size. And then we want to do an arc around the outside here so we can curve the outside of our support. So we'll press arc, and we want to do the center point of the arc. We want to click at the center here and all the way to the edge. And then we just drag our line across, and then we'll go to there. And then we're going to have that shape. I'll give you a minute to catch up to that. Okay, so you have this shape over here. We're going to finish this sketch. Now when we extrude it, we want to cut this internal circle and we cut these corners. So we're going to go to extrude. We're going to select all these shapes over here, all these parts, and then we're going to go backwards, and it's going to cut off that. And then we have that shape. Then we're going to sketch, and we're going to sketch on this flat profile over here on the side. Everyone look, boys, all on the board. We're going to press this flat surface over here for the next sketch. And what it's going to do is going to give us our shape over here. And then what we're going to do here is, I'll show you on the other example, is we're going to make this hollow. So to do this, we have this shape over here. We're going to press a rectangle, and we're just going to make a rectangle that covers over the shape that we want. And all we're going to do is we're going to do the same approach. We're going to cut this out. So it's going to remove this center section. Finish that sketch, and then we select our two shapes we want when we do our extrude, this one, and then we go backwards, and then we're going to make that shape. It's going to be our two hinges basically for the top of our syringe. Okay, and I'm going to do the same thing for the base as well, so you get to watch me do it again. Create sketch over here, Again, we care about where the center is, so I'm going to start by making a line. Now, when we have this line over here, the important thing is, when we make this line, if your top one was not in the center, wherever your top one was, if you decide to put it on the side or you decide to have two of them, that's fine, but you've got to make sure the other end matches that, because they're going to have to be aligned. They should be aligned in real life, but they will definitely have to be aligned in your drawing. So I did mine in the center, so I can now make my rectangle from the center, and I can have it over here. And I'm just going to make this the same size as the previous one. (5x10), and then I'll extrude, and I'll extrude this side and that side. I'm going to extrude it by 10. Nope, not by 10, I'm going to extrude it by 5 to make that rectangle. And then I am going to sketch. I'll sketch over here. I will make my line. Now, when you make your diagonal line, you actually don't even have to do two lines necessarily, because we have one line. When we go to do our sketch, when we bring our marker, we bring our marker close to the center, we get that triangle, which means that's the midpoint. And we'll do that, and we'll do the same thing with our circle, make it 3 mil. You also do not have to use the arc tool. I like the arc tool because it's more specific, but you can also get away with doing a circle by pressing the dot here and dragging a circle all the way to the edge. Then when we do our extrusion, all we have to do is we just have to make sure we select the parts that we want to remove as reversing. So we want to remove this part, and remove this part, and this part, and these two. So you can do a circle. You don't have to necessarily do an arc. And then we go backwards, and we have that. Done. And then we'll sketch down here. And we'll make that rectangle shape we asked for before. Okay, so that is where we're up to here. That is the completion. This is all I need for the bridge part for it to work with an assembly. So I'm going to save this. So now we have the top and the base of our bridge. I'm actually going to rename these because it's going to be helpful for us as we refer to them later. So we can call this as the base of the bridge, and this can be the I guess road, right? We just know what this is. We can name those particular parts. We're going to put them into. I'm going to put them into the assembly. So what we need to do is we have to find like the distance of the size of the syringe. So we haven't made the syringe yet. We're going to look at our design and we can see what we can do with that. So we're going to make sure we save it before we do anything else. And then we're going to press add to assembly over here in the top right. Oh, before we do that, we've got to confirm we have two bodies. We need two separate bodies. Add to assembly. We press add to assembly. We press this button. We are starting with a new assembly. So we'll press new assembly. And our thing's in here. Now, when we add in a part to an assembly, a part that we've made, that includes all the bodies in the part. If we look when I try to rotate it, I can't just rotate one individual body in the part. It's all going to rotate together, which is not our goal. Because Fusion is designed when you actually have multiple separate parts that should each be their own file, really. We're doing it in a easier way that's for us to build it as all one file. And we can do that, but we've got to think as we're bringing this in, everything from the same file is going to want to move together. So we have this here. If we look at my example I did here earlier today, how I did this is I actually have the same part in here multiple times. I have the same part in here multiple times. So this is the first one that we brought in with the base and the road. And what I'm going to do here, if I expand it on this tree here and I expand the bodies, I am going to make the first one be the base and I'm going to hide the road. So now there's only the base over here. So then I'm going to add in the file again. So I'm going to, up here in the top left, I'm going to insert a component. And this is where I have to look in my files for the one I made previously, which was 2026 Task 3 Tutorial Bridge. We press that and I press Insert. And as the bridge now, if we actually look at this, it's still got the base part there, right? So we're going to have to hide that. I'll bring this down. I'll press OK. And for this one, I'm going to hide the base. So now I have the base and the road. I'm then going to do the first relationship to make these two components move relative to each other. Now, the first thing we notice here before we start anything, if we look over here, this symbol, there's a little hook here or an anchor. That means that this part, this component, the first one we added, this is going to be the one that should not move. Everything in our design should move relative to this particular part. I would make this typically the base of my design, but you might change it at some point, but that's the part, everything else has to move relative to that. I am then going to make, I'm going to go to relationships, and I'm going to make a joints. This is the joint menu over here. What we have in our joint, we have component 1 and we have component 2. Fusion has to be very specific with joints. You can only do 2 parts together. If you want to have multiple things connected together, like, you have multiple parts, each of them have to be an own individual joint and they add up. So if you say A has to be connected to B, but then B is also connected to C, by extension, A is then also connected to C. Because every time we try to move B and C, it's going to also still have to be connected to A. That's how we get our piston examples on the previous one, how they move relative to the other joints as well. So when we do our joints, we can go over here. The most common joint is the rigid joint. That's if you have 2 parts that you don't want them to move relative to each other. So if you have like a cell phone in a cell phone case, the cell phone can be a body and the case can be another one. You want them to always move relative to each other. That is a rigid joint. They're going to be always connected together. For this one, we want to do a revolve. We want to make it revolve like a hinge. The wording they use here is revolute. That's our motion we want. We want it to revolve. Then we go to our position. We'll pick component 1 and component 2. As we now bring our mouse over our bodies, we see here a new icon is showing up. It's showing a face, and then it's got these little points of interest on here, so we can like attach it somewhere. This is going to see we want this to rotate around it. Now, do we see that little icon we have there? It's like a circle showing that this is how this thing is going to rotate. So we think about where the hinge is going to be if we were connecting these 2 parts together. This could be like if there was an axle connecting it, or if it's a piece of sticky tape with allowing it to rotate or flex, like if you had folded a piece of paper. So with this object over here, we want to go to the corner. Now the problem we have is as we go to the corner, depending on how you move your mouse, it's hard to tell exactly what's being connected. Is this one being connected or is this one being connected? So what I found out is first you bring your mouse over to the plane that you want to deal with. So we want to deal with this plane. And then if we hold our control button, as we move, is it control? We press the control button, and then what that will do is it'll let us move our mouse to any of these points of interest. So I want to bring it up to here, and I want to press that. So this has been selected. As soon as you select the body, it will automatically hide it for you. So that's convenient. So now it's saying, all right, you can't connect an object to itself. So I've hidden that. Now, every other object, what do you want to connect it to? Well, I want it to revolve around this corner over here because they're overlapping. So I'm going to do the same thing. I'm going to hover my mouse over here, hold down the control button, bring my mouse to the corner here, and watch what happens as soon as I press this. The screen's going to move. Oh, that's not very nice, is it? We can. Yes, we press this flip button to rotate it because it's got to do with, like, we saw that axis coming out to the X. It tries to align those axes mathematically, and so sometimes that can do a 180 flip. So you press this flip button. You can actually also do offsetting if you must. You can force it to do an offset, which can be useful if, like, you're doing your piston or something and you need to align. But we did our drawing very nice. We did it nice and symmetric. So when we press OK, and when we press OK, it should actually show the animation. No? Okay, never mind. It won't. But if we go over here, so now how do we do this? Up here we have now the relationships tab is opened. We can open that. We have our joints, and we have our revolute joint, and we can actually right click this joint and we can say animate. I do feel like it's not attached. That does right, yes. So, when you make a joint, I don't know if it always happens this way. It's weird. I even get it wrong. When I'm making a joint, and if you look at the joint menu over here, when you make a joint, the first joint you make is the body from the first one is the one that's going to move by default. The second one is not going to move. And that is just for the joint itself. So when we did this and we animated this, if I animate just this joint, animate joint, the first one we make is the one that's going to move. The second one is not going to move. That's by definition for the joint. But if we then think outside of that joint, if we look at our whole model, we also have another description, another rule out here where we said, well, we want this one over here, the block number 1, which is this has the anchor. We want this to be grounded. So if we actually right-click this joint over here and we say animate joint relationships, that says animate this joint and every other rule that's associated with this joint. So now if we do this, now it's saying, well, all I know is the joint these have to move relative to each other. Are there any other rules? Yes, the base has to also be the grounded one. So that's why the other joint is moving. Now this, I mean, it's technically doing the right thing we want. It is rotating. Obviously, it's unrealistic because it's doing a full 360. We can change that, but we'll change that later. What we really care about is if I press the escape button, if I double press this arrow, I can adjust the joint here and I can adjust some angles. So what I want to do here is the reason why we're doing this before we've completed our piston is if I say, if I want my bridge to go up to 60 degrees, right? In my sketch, that's what I'm saying on my design. I can make it up by 60 degrees. I need to know how far these holes are when they're at 60 degrees. And then I have to know how far my holes are apart when they're at 0 degrees, because that's going to be the minimum and maximum distance my piston would have to do. So let's first do the 0 degree one. We can go to 0 degree and I'm going to go to my inspector. I'm going to go to measure and I'm going to inspect this center hole to this center hole. And now there's 2 dimensions that are overlapped here, which is a bit annoying, but we don't want the minimum distance. We want the actual distance. So when our bridge is closed, 31.8 millimeters. So when I'm doing my piston, it has to be at least 31.8 millimeters. Has to be the minimum distance that my piston can be completely. That's both the case and the piston. 31.8. Then I'll close this. I'll do the same thing over here. I'm going to open this joint up. I'll go to 60 degrees and I'll inspect between this and this. And now that is 47. So I needed to go from 31 to 47. That's the size I need my piston to do at least. We're going to mentally write those numbers down. I'm going to write them down on my notepad. because we're going to be referring to those as we do our next part, which will be the piston. I'm just writing on my notes. We've got 31.8, and the other distance is 47. All right, that's all we need to know from this particular part. Everything else, we'll just save this for now. Save. Yep, bridge assembly, we'll call it the assembly. Save. Let's make a new body now. Actually, I'll pause us for a bit. So now that we've got our maximum and minimum length, and I have mine written down in my notepad. Now, I think Fusion even has a notepad feature somewhere. I just don't know how to use it. But is there comments? Where is it? Oh, wonderful. I can even write it here. 31.8. $47, which means when I make my piston, I have to make it smaller than 31.8. And the maximum it has to reach is 47. If I wanted to do a full 60 degrees. Okay, so, and I don't know if I was going to stay in there, but when I start my new design, we're going to make a new part, create new. The comments aren't going to exist in my new part, but I can measure those later. Shh. Boys, it's getting picked up by the mic. Stop. So I'm going to make my piston. If I know the minimum length of my piston, have we seen what the syringes look like? The syringes have a base, and then you have a plunger inside it. So I know the base plus the plunger have to be 31.8 combined. So I'm going to make it, I'm going to start by making my sketch. I'm going to start by making a circle. And I also know from when I did my gap in my support that we had like a 7mm hole there. But sorry, by gap in the hole, I meant this thing over here, this gap between these two is 7mm. So I want to make it look like it fits inside there because it's going to look nicer. So let's just pick a number. When we do our circle, I want it to be 6mm. 6mm is the cylinder. I'll press OK. And for how large I want my cylinder to be, I'm going to extrude it. Now, I don't want it to be 31.8 because I still need room for the plunger, because if you've seen a syringe, they have that area where your thumb presses on it. It sticks out a bit. So I don't want it to be 38.1. I actually want it to be smaller. So I'm going to pick it 29. This is the outside case of our syringe in its simplest form. Another feature I want to add for my syringe to start to make it look nice so we can get some concepts about what's happening here is I want to know which part of my syringe is going to have like the needle coming out of it, because I can see if that's going to hit any other parts of my design. And again, when we get our actual syringes, you can measure these, but I think it's 3mm is the outside plastic of the syringe. How far it goes out, I do not know. So I'm just going to visualize it. I think it'll go out like maybe that far. 3, that doesn't look, no, 3 down, okay, sure. Let's just say that's could be the outside of the syringe. That could be what it looks like. Maybe we'll go with that. Now, a part that we do need is we need somewhere, if we look at my example over here, the piston needs something that's going to go inside our hole we have here, a rotation. So our piston's going to have a circle that we can connect the axle to or something like that. So I'm going to go sketch here. I'm going to make a circle. And I'm going to make this 3mm. And then I'm going to extrude this. Oh, so I'll finish this sketch. I'm going to extrude this circle. And I want to come out till at least 5, let's say 6. And I don't want this to cut. I want this to join And I want this to be symmetric because it's going to come out both sides. Now, this isn't the greatest looking design we've had here, but whatever. This, you could glue these little things onto your syringe wherever it makes sense, right? This is actually where we're going to be measuring our distance from, because this is going to go inside this hole here. Then we want to make the plunger. I'm going to make the plunger. So for the plunger, I'm going to go to sketch. I'm going to sketch like this, and I'm going to draw a rectangle. And this rectangle, I'm going to start it just off the base. I don't want it to hit all the way to the base because I'm going to cut this out of our piston. So I want it to be just higher than the base. And I want this to be, this can be 30 mil. It's going to be slightly higher. And for its width, if I pick 3 mil, oh sorry, I want it to be 30 mil. Yep, 30 mil. If I pick 1.5, no, we're not. If I pick 3, it's going to be the total length of the plunger, because the plunger is 6 millimeters in diameter, but I want to make it slightly smaller. So let's say I want it to be 3 minus, let's make it 2. Right. That is basically what our plunger is going to look like, but I can also start to make it look a bit pretty so we can visually understand what's happening here. I will, actually no, I'll make it pretty later. Finish this sketch. Just a rectangle inside there. I'm going to revolve this rectangle I made here. The axis is going to be the center axis. By default, it wants to cut, but I don't want to cut it yet. I want to make it a new body. It's going to be a new body inside there. And if I hide the original, press OK. If I hide this, that's what our plunger looks like over there. And then I can also start to make my plunger start to look a bit prettier by, I can sketch it again. I can make a rectangle shape like this. Which is offset. And then if I revolve this, the axis I want that revolved around is this one. And so I'm just cutting out the center, basically. And press OK. That's basically what the inside of our plunger looks like. And then I can also make the outside, so I can make the, where your thumb is on the plunger, I can make that larger by doing press and pull. And I can press this surface over here, and I can make it larger by just dragging it out like this. And press OK. So that's basically what our syringe looks like. I can do things where I can even check now, I can check some lengths. Also the top half, it also needs a cylinder. So I'm going to do the same thing I did with the base. I'm going to go here. I'm going to make a circle. I'll make a 3 millimeter circle. And then go here. We'll extrude 6. And we want it to both sides. That's basically our syringe. Now, the one thing I want to do before we finish is to make it look kind of nicer, which can be visually more understanding, is I'll hide the piston. This is not hollow. Shh, that's enough. Stop. This is not hollow. So I'm just going to go here and I'm going to sketch a circle here. 5. And I'm going to extrude this down, this little circle, I'm going to extrude it down most of the way. So I don't want it to be 29, but I want it to be like minus 28. So it's like slightly off the bottom. Minus 28.5. I press OK. So now this is hollow. So when I look at it, I can clearly see this is hollow. And I can put my piston. Now the issue we have is we've determined that the minimum height, well, we can test the minimum height. We can go to our inspect tool and we can say, well, the distance between this circle and this circle is, from the center to the center, is 32. Oh, it's slightly too large, but 31.8. I think I made a little bit of extra space. I can just shrink it slightly more. I can make them compact into each other. It should be fine. And when I want to extend it, the distance I care about for extending it is, I want to know what the distance is when this is fully out. So I can do this body over here. Move this body. I want to see if I fully move this. If I move it like that, where the piston's fully out or almost out, and then I measure this, this has to be more than 47. 59. So we have plenty of room to move here. This can go up to 59 centimeters. So this can easily do our 60 degrees. I'm going to undo that. So we have that. So now we have our piston here. And for the sake of the demonstration, actually I'll change it later like I did with my test. I have to save this, save. Again, I'm going to save in the same location. This one I'm going to call 2026 task 3 tut piston. And I'll actually rename these bodies. So this can be the piston case, piston plunger. Right. Got these words, and I'll save it again because I named these new bodies. So now I want to add this to the assembly. I go to this assembly over here. Insert. We're going to find that. If we go to last updated over here, we have this piston over here. Insert. Now notice how this one is all the way to the side. It's not correct. This is where we're going to have to worry about aligning our object. So when we align this, well, first thing we're going to do is we're going to press OK. We'll just do one at a time. I'm going to start by doing the housing, and then I'll do the plunger, and they should all be connected in the end. So we'll do the same thing with our bridge. We'll go to our bodies. We will we're going to hide the plunger. So we just have the case. We know that this cylinder over here is going to have to line up with these holes. But also it could be able to slide left and right. So when we go to our relationships, we're going to go to joints. And for this one, we want to go to motion, and we want to do the revolve again. Go to position, and we want, what do we say? The first one we select is the one that moves, right? So we want to press this cylinder over here. This is one where you probably do want to use the control button, because as this cylinder over here, we'll hold our control button because we want to press this dot over here. That's the axis we want this cylinder to rotate around. And we want to hold our mouse on the inside of the cylinder and then hover over here. And now that moves that there. Now this one we will have to offset, because see how it's not aligned this way, right? So this one we will offset, we'll have to manually move it to where we want it to be. And then we press OK. And we can test this by going over here, right click, we can animate this joint. Yes, that's moving in the correct direction that we want that to move. We won't worry about the limits yet. Okay, now let's insert the other one. Insert, update, piston, insert. This one we want to hide the case and press OK. This one's just the plunger. We want to do a similar thing, but there's one key difference we're doing here. One key difference. I'll show you what the key difference is. It's important. You're going to go relationships, joints, as before. When we go here, we don't want to do a revolve joint. For this one, we want to make this a cylindrical joint. The reason is when we have a revolve joint, it allows two objects to rotate relative to each other, but they can't slide back and forth. Right? So it's like, imagine the hinge on a door. They can rotate, but the door can't move up and down relative to the door's location. Which is fine if it's just a single joint, but because we're going to have multiple joints that want to connect to each other, we need to allow one of the joints to be able to slide to fit into place, because we're saying this joint down here cannot move left and right. It has to be locked in that left and rightness. If we have the top one, and if we also lock that in the left and right, we might be in a situation where they physically cannot be inside each other because they could be unaligned. So we need to allow this top part to be able to move left and right here, to slide back and forth, but also to revolve relative to each other. And that's why we do the cylindrical joints. We'll go to position, and we'll do the same thing as before. We'll go over here, we'll hover here, press the control, and we'll go over here, and we'll press this one over here. Now for this one, I'll show you, we don't have to actually align this one because it's a cylindrical joint. It should, if we did everything correct, it should align itself when we finish our thing. But we'll press OK. And now if I animate this joint, we'll see here it's showing this is what the joint can do. It can move back and forwards, and it can rotate. We need this one to be more freedoms for this one because it's going to be constrained by other things later. Cool. Now, what's the next joint? What's stopping this from being a completed task? Look at my example over here. We're missing this joint. We're missing these two pistons being connected together. We know if we can describe it, we're saying the outside of the housing and the inside, they have to be aligned together. So we're going to make our last relationship, joints. And we'll go to motion. And this one also is you can pick slider or you can pick a cylindrical joint. They should both work. We'll pick cylindrical joints. Doesn't matter which one actually moves in this one, but we know that this plunger, that's the axis of the plunger, has to be, now I'm just going to hide these for this. I said the axis of the plunger has to be the same as the axis of this cylinder over here. Shh. So that's the animation we want. Right, I'll show that animation over here. That's the animation we want. Now, obviously, we have to refine it and lock it in place later, but that's what we're looking at. So now when I have everything unhidden, right, there we go. Our tower is, our bridge is all ready to go. Doesn't it look wonderful? Perfect, right? So let's look what happens here. I can animate each of these parts individually. We have this part, that joint is done. We have this, that's the axis of the cylinder case, that's done. We have the top sliding back and forth. And then we have this one over here inside the cylinder tube. Now, if everything works great and I press this button over here and I animate this, nope, wrong button. Right click, animate joint relationships. No, okay. What's happening? Why isn't this working? Oh, that was our first joint, sorry. If I animate this over here, animate joint relationships, they are all moving relative to, they're all moving relative to each other. This is wonderful, this is beautiful, sort of. It's somewhat working. So what's limited here is we have to clearly do some definitions for what the minimum and maximum of this moving is. So I'm going to relate everything to the hinge that is the bridge. So I'm going to right click this joint over here, and I can actually rename this bridge joint hinge. If I right click this, I want to edit the limits. When we did our example and we were moving this previously, we said our minimum was, well, our maximum was 0 and our minimum was minus 60 when we were moving it manually. Perfect. So now, if I go here and animate relationships, now that's looking better, right? That's looking like how the piston should actually move. So we've figured out the length of our piston, we've figured out how it moves. Now, why we bothered doing this animation in general is, firstly, the animation looks very nice, and you can import this into your report. You can show, once you get more and more complicated parts, it starts to look better. We can also do things like, as we're doing our animation, we can see here that, I'm actually going to stop it. We can do it at certain angles, so this is at 60 degrees. We can clearly see here that our piston, our circular part of where the thumb goes, is too big for our model. So I'm going to have to cut this down. We also see that it's going to touch over here. Right, it's overlapping here. I think there is actually options where you can actually do interference. Compute. Oh, okay. Did that work? Interference between this and this. Compute. Yeah, it's found out what parts here, there you go. It's actually found out what parts are overlapping. I wouldn't even use that though. I'll just do it visually for now. We know as we're doing our circle, I'm going to have to overlap it. Also, but when we do this length, why we bothered finding out this over here, when I bring this rotation down, right, when I bring this down to 0 degrees, boys, that's enough. Stop. I'm almost done. I've got this, and I've got one more thing to show you. When we bring it down to 0 degrees, clearly our needle here, where we're going to put the plastic tube, that's also overlapping. So how can I fix this design? If you had to change the design, what could you do to make it so that where the needle part is, where that's not going into your model, how could you change this? Someone give me an idea. Right, this needle over here is going into our box. How could we change this design so the needle doesn't go into the box? Yes? Make the needle shorter. Yes, you can cut the needle down. I wouldn't though, because you got the tubing on it. But by the same extent, if you want to make the needle shorter, what can you make longer? So over here, the supports, exactly. This support, we made it close here. You can just make the support longer as well, so it's offset by more distance. So that's why we bothered modeling the needle in there. You can also do things like, we can save this, sure. I'm going to show you how, as you change your design, things should automatically update. If we want to change our design, and we go over here, if I said, I actually want this case to be transparent plastic. So I'm going to right click, I'm going to go to appearance, and I'm going to type in clear, and I'm going to type clear acrylic. I'm going to drag acrylic over here. So now this is transparent. I'll press close, and I'm going to make sure I save this. If I go to my assembly over here, we see here now there's this little yellow refresh symbol over here which says this part has been saved and updated. If I right click it and I say get latest, it's going to look at the files, and now this change is here. So now when I animate this, I can better see where my piston is inside here. Okay, so you can change that in your drawing. You could also do things like you could change, let's say another example, if you wanted to make parts of the support so this didn't touch in here, we could do stuff like go over here. Let's say I want to gouge out certain parts in here so the needle doesn't touch. Seven, 15. So let's say in my model, I'm designing it so I make this a hole in here that's larger, right, in my design, and I can save this. And then if I go to my actual assembly, again, I'll update it. These have been saved. So they've got their update symbol. I right click, I say get latest. And now if I look at that, there we go. Now it's no longer touching. Right, so you can update your model. You'll save this. You can do more and more complicated. The next tutorial I'll do, you might not get it. I might do it a fully online one. I'm going to show you how you can actually make the master piston move. So as you move the master piston, the save piston is going to move at a different rate. So the piston can be a different size. Before I close the tutorial, do we have any questions to be saved on the tutorial? No? Wonderful. You'd also pretty this up by maybe put a hinge here later. You can draw those parts later. You can make the hinge look nicer. You can do the rest of your bridge. You can do patterns, whatever. I'm just showing you here the concept of getting the hinges moving relative to each other.